this computer. Again, the goal is basically to get your math skills up. You know, that's the goal. The secondary goal is that you pass the exam, but first get your math skill up. So let's go ahead and do blacking. So we got 2C. This is for section 6D. We were doing 1 through 4 all. Okay. So 2C, 3C, any other ones? Okay, 4A. 4H, what else? I hope this is enough space for me to write. What else? 2E, okay. 2E. What else? 4D. Anything else? All right, remember, guys, so this is the time we have. So the whole point here is that you use this time as the best you can. I know we're missing a lot of kids to ACE testing right now, but I mean, the show has to go on. So 2C, it says find f of prime of -2, f of prime of -2, and they give us the function 1 minus 2x, 1 minus 2x minus 3x squared plus 4x to the third. So let's call this f of x. So first thing we do is we find f prime of x. What's the derivative of 1? 0. What's the derivative of -2x? -2. What's the derivative of -3x squared? -6x. What's the derivative of 4x to the third? So far, so good. So they're asking us to find f of prime of 2, which is just going to be -2. Oh, -2, sorry. F of -2. F of prime of -2. F of prime of -2. So 6 times -2 plus 12, -2 squared. That's what you would do. And then you just go ahead and do this. -2 plus 12 plus 12 times 4. So that's -2 plus 12 plus 48. So that's 10 plus 48. And is that what you got? 58? Super easy, right? Super easy. So let's do 2E now. 2E says we have f of x is x squared times 1 plus x. Now, we have a rule that we can use to apply it just like this. But when you see something like this, just go ahead and just, you know, use distributive property. Write it in a way that you have exponents like that. Because we do have a rule called the product rule for derivatives, but I still haven't taught it to you, and it's probably not in the scope of this book, but I might teach it to you anyways, but it doesn't matter. Now I hear it's trivial. You can just apply the power rule as is. Right. And then you just have f prime of -2 equals, and you substitute now. Now, something that I'm kind of not saying, but that we should always be thinking when we're doing derivatives. This number that you're acquiring right now, this number here that we end up having here, 8, that 8 is the slope of the tangent line at that point, or at that x value. Same thing with the previous one. Throughout that function, the original function, the slope of the tangent line changes as the function changes. And the derivative allows us to determine that slope across all values that we can think of that are allowable for that function. So remember, whenever you do the derivative, whatever you get is the slope for the tangent line. Do we understand? Yeah, why not? And you know, how many of you are happy that you got a good grade in the last test and that you're kind of understanding this? You know, so that's good. That's exactly, and that's the type you should be happy. And if you continue working on this, you know, imagine if you're taking like calculus in college, you know. I think it's something that you can look forward to, and it's not as magical as people make it out to be, and it is achievable by others, you know. Just understanding these concepts, it makes you appreciate the math. It does, especially when you start doing higher level stuff. You're like, oh wow, it's kind of beautiful. So, well, I mean, you just do FOIL here, right? So let's do FOIL. 1 times 1 is 1. 1 times negative x is negative x. 1 times x squared is positive x squared. X times 1 is x. X times negative x is negative x squared. And then you have x times x squared is x to the third. Combine like terms, obviously. So looks like this cancels out. This cancels out. You have 1 plus x to the third. So something simple like that. And then so f prime of x, apply your power rule as is. Derivative of 1 is 0. Derivative of x to the third is 3x squared. So we end up with 3x squared. And then f prime of -2 is 3 times -2 squared. -2 times -2 is 4. So it's 3 times 4. You end up with 12. And that 12 is the slope of your tangent line. Okay, so for 2f, do you see how I found the derivative? Okay, so we're right here. We have 2 terms there. We have 1 and we have x to the third. Now 1 is a fancy way of writing x to the 0. If we look at the rule says x to the n, if you have this function here, the derivative to that function is n times x n minus 1. All right. So obviously for x to the third, 3 times 1 is 3 times x, 3 minus 1 is 2. So that's how I came up with at 3x squared. Now, the 1 is a fancy way of me writing x to the 0 because we know x to the 0 is 1. So 0 times 1 is 0. X to a -1. So it's 0 over x. So it's just 0. In fact, for any constant, for any number by itself, the derivative is always 0. So that's how I came up with the derivative. If we look at the previous one, here, you have x squared, and you have x to the third. So 2 times 1 is 2. X, 2 minus 1 is 1. So the derivative of x squared is 2x. That's why we got this. And then 3 times 1 is 3. X, 3 minus 1 is 2. And that's how we got that derivative. That's the game we're playing now. It can be more complex, but that's what we're doing now. Does that make sense? That's all we're doing. That's all we're doing. Any other questions on number 2? Why is this coming out here in the corner here? I don't know. All right, so let's take a look at the next number we wanted to do is 3c. So in 3c, they give you 3x minus 3x squared plus x squared. I'm going to forget that. 3x plus x squared. And then x to the third, sorry. And then they wrote the 108 here, meaning that they want you to find f prime of x such that you have 108. I think that's what they wanted you to do in those instructions. Oh my gosh, look what happened there. Yeah, that's what they want you to do. So in this case, they wanted f prime of x to equal that number instead of setting f of prime of x to something. All right, so let's go over this. So here's our function. Can somebody tell me what is the derivative of 3x? It's just 3. Now, here's how it is. 3x is 3x to the first power. 3 times 1 is 3. X, 1 minus 1 is 0. X to the 0 is just 3 times 1, so it's just 3. So anything that's just to the first power, x to the first power, whatever the coefficient is the derivative. It's a constant function. It makes sense because it's a line. Now, how about for the next one, 3x squared? What would it be? Negative 6x. Negative 3x squared. 2 times negative 3 is negative 6x. 2 minus 1 is 1, 6x. Negative 6x. And next one will be what? So 3x squared. Just to make sure, because I don't want to make the assumption that this is so easy, everybody understands it. 3 times 1 is 3. X, 3 minus 1 is 2. Now remember, last class, I went through the trouble of doing the limit of f of x plus h minus f of x all divided by h as h approaches 0, and showed you for different functions so we can see a pattern and we can derive the power rule of doing this, and we just trust it. Okay? So there we go. So now what does f prime of x equal to? F prime of x equals to f prime of x equals to 108. So 3x squared minus 6x plus 3 equals 108. Or you can write 3x squared minus 6x minus 105 equals 0. Or you can factor that. 3x squared, 3 times x squared minus 2x. So 33, 34, 35. 105 divided by 3 is what? 35. So I can write this now. Make sense? So far, so good, right? If I divide both sides by 3, what do I have left? Agreed? I can do that. If I divide 3 to both sides, 3 cancels and 0 divided by 3 is just 0. You can see that's easily factorable, right? X minus 7 times x plus 5. And you can see that the two answers are, you could just write it here, x equals 7 and x equals to 5. Negative 5, say. And that's it. You see why it's so important to know how to solve and factor quadratics? Because you can't do a lot of the problems because you don't have the tools. Is that clear? Is it clear enough for you guys? I mean, I know you should be able to follow. And again, this is just practice. If you're struggling, then you just need more practice. That's why I'm gonna give you plenty of quizzes and tests to motivate you to practice. Without the quizzes or tests, you have no reason to practice. Assuming you care about your grades. If you don't care, so, and here's another thing. Some of you, woo-hoo, I don't care, bro. If you're not there, get there. It just takes practice. It's no different than getting in shape. You know, you just do it, and then it clicks. It clicks. Keep on doing it, keep on struggling, and it'll click. And then before you know it, you can actually pick a decent major in college and not have to major in English. I'm just saying. English is a good major. I'm just saying. If you can't do math. But so many more majors are, look, a lot of kids who go try and become a doctor, they can't get through calculus. They can't take the physics. They're watering down the requirements sometimes, but come on, really? You're gonna do well on your MCAT on that standardized test if you don't have strong math skills? Chemistry is tough. So it's all about just working on this. So this is not going to be a hurdle for you, an obstacle in the future. It might be a small obstacle, but not a big obstacle. Okay, what else do we want to do? 4E and 4H. 4E and 4H. Let's do 4E first. And I think I'm going to have to scroll this to the, yeah. Am I being pretty clear, guys? You're good, right? You understand? If you have questions, let me know. Because I'm trying to pretend to be a teacher. Okay, next one. So this one says that they want you to just differentiate it. Okay. So you have, I think it's x minus 1 over x. This is the function they give you, right? So this is x to the first power minus, what is this here? How can you rewrite that? Is that right? So now you can do it. What's the derivative of x to the first power? Just 1. And what's the derivative of this one here? Negative 1 times negative 1, that's positive 2x to the negative 2 power. So you can rewrite this as 1 plus 2 over x squared. Because we realize that negative power in the numerator is really a positive power in the denominator. Does that make sense? Okay, so I'm gonna make a bubble in rainbow color now. Let's just look at this here. -1, x to the -1. What's -1 times -1? Thank you. Now, does it feel better? Okay, okay. What's -1 times -1? +1. X to the what? What's -1 minus 1? There it is, yeah, -2. So you see it, right? Okay, sorry about that too. Yeah, I know, it confuses you. Sorry about that. So it's 1 plus 1 over x squared. Tired. All right. I'm not really that tired, but yeah, I'm tired, sort of. And H, right? Let's do H together. Is there enough space there? Yes. I'll also do D. So let's do 4H first. 4H is some weird square root. Oh my gosh. You guys are gonna make me work. Square root of x plus x divided by square root of x. And then everything squared. Like that, I think. Yeah, I think I wrote it right. All right, so what do we do with these square roots? Can we rewrite the square roots in terms of exponents? So let's just write f of x equals x to the half plus x divided by x to the half, but all this squared. Wonderful. So now this means x to the half plus x squared and x to the half squared. Well, this means x to the half plus x times x to the half plus x. And the bottom is just x to the 2 over 2. Because half times 2 is 2 over 2, which is just 1. So now, x to the half times x to the half, what would that be? What do we do when we multiply like that? What do the exponents do? They add, right? What's half plus half? 1. Then we have x to the half times x to the first. That should come out to x to the 1.5 or 3 halves. Then you do it again here. Then you get another x to the 3 halves because you're adding the exponents. And then you get 1 to 1, that's x to the second. Right? Because the last one be x to the first power times x to the first power, that's x to the second power. And then you can divide this by x. And now you can combine like terms. So you have, basically you have x to the second plus 2x to the 3 halves plus x divided by x. Now you realize you can factor out an x there on the numerator. And you can write x like that. So x times x is x squared plus 2, well, x to the half here, plus 1, all divided by x. And now you realize that the x's cancel each other. So you have x plus 2x to the half plus 1. And So now let me nicely write it here. So if f of x equals x plus 2x to the half plus 1, f prime of x equals 1 plus half times 2 is 1, x to the negative half. And the derivative of 1 is just 0. So you might want to rewrite this as 1 plus 1 over x to the half, or 1 plus 1 over the square root of x. Wow, is that simple? Can you check my answer? Make sure I didn't make a dumb mistake, but it looks simple to me. Maybe I'm right. Maybe I'm wrong. I don't care. This is 4H. It's right. So this is a hand-picked question that comes out beautifully. Are you guys good? Make sense? What other question you guys want me to do? Any other one? Only if you're careful. We're good? We're good, good. Are you sure? Any questions? No questions? All right, so let me go ahead and stop this share. And I'm gonna go ahead and stop this recording.